All right, so the first thing I'm going to do on number 1 is I'm going to pick 2 angles that I could add together to give me 105. So looking at your choices there, which 2 would you add together to give you 105? Good, yeah, 60 and 45. Very good job. Okay, you can also do that as 45 plus 60. The order does not matter because you're adding. Okay, the order does not matter because you're adding. Okay. All right, so what I'm going to do is I'm going to let 60 be my alpha, and I'm going to let 45 be my beta, and I'm going to go over here and take a look at my formula. Okay, I'm working with sine, so I'm going to use this top formula up here that says to do the sine of alpha cosine of beta, and then I'm adding, so I'm going to add, and then I'm going to do cosine of alpha sine of beta. Okay, so back over here, I'm going to do the sine of alpha, cosine of beta, plus the cosine of alpha and the sine of beta. Okay, so all I did there was plug into that formula that, again, I'm going to give you on the test. Okay, next I'm going to put some parentheses down here so that I have something to fill in. I personally like to fill in my 45s first because those are my pi over 4s, and they're a little bit easier to fill in because both sine and cosine is the square root of 2 over 2. It does not matter which order you go in, but I personally like to do those first just because they're easier on my brain. Okay, up there at 60 degrees, I'm working with pi over 3 right here. So pi over 3, I know that my cosine value is 1/2, and my sine value is the square root of 3 over 2. And if you're a little bit fuzzy on that unit circle, you may want to go back and look over unit circle. Okay, and then I want to do top times top, and bottom times bottom, and top times top, and bottom times bottom, and that's going to give me the square root of 6 plus the square root of 2, all divided by 4. What's nice about these is that they come out with a common denominator, so you can go back and just add those things together. If you had done 45 plus 60, you would get the square root of 2 plus the square root of 6 on the top, which is the same answer, so whichever order those are in, it does not matter. Somebody last period said, can you just put the sine of 105 in your calculator? You can. The problem is that that does not give you an exact answer. Anything decimal is considered a rounded answer, and MathFrac will not change it into the square root of 6 plus the square root of 2 divided by 4. But wouldn't it be nice if it did? But it doesn't. So that's why we're doing these, is they give you that exact answer that you need. Okay, any questions on number 1? Okay, let's jump over and take a look at number 7. We did one kind of similar to number 7 yesterday, but I want to look at this one because we're going to work something with it on the back side in just a few minutes. All right, so I'm finding the cosine of 5 pi over 12. Again, I want to look up there at my unit circle and find 2 things that would add together to give me 5 pi over 12. Okay, so looking at what I have up here, which 2 angles would you add together to give you 5 pi over 12? That's right, good, yeah, 3 pi over 12 and 2 pi over 12, which I'm going to reduce down to pi over 4 and pi over 6. Okay, and again, if you have 2 pi over 12 plus 3 pi over 12, that's okay. All right, I'm going to go use my cosine formula. All right, so look at your cosine formula. And my cosine formula says, I'm going to make this one alpha and this one beta. It says to do cosine alpha, cosine beta. Notice it has the opposite sign, so if this is a plus, this is going to be a minus. And then it's going to be sine alpha, sine beta. Okay, so again, I got that from those formulas that I'm going to give you on the test. You do not need to memorize formulas. All right, let's fill in what we have. All right, again, I like to do my pi over 4s first because I know both my sine and my cosine values are the square root of 2 over 2. All right, This time we're working down here at pi over 6. And at pi over 6, I know that my cosine value is the square root of 3 over 2, and I know my sine value is 1/2. All right, top times top, bottom times bottom, top times top, bottom times bottom, and that will give me the square root of 6 minus the square root of 2, all divided by 4. What you'll notice about these is that because we're working with unit circle stuff, you get a lot of square root of 6s and square root of 2s divided by 4. It doesn't happen every time, but you'll get a lot of these same types of answers. If you got on this one negative square root of 2 plus the square root of 6 divided by 4, that's okay too. Okay, they're the same answer either way. All right, any questions on that one? Okay, on the next set, 9 through 12, they are just asking you to fill in the formulas. So they've already told you, like on number 9, to use the cosine sum formula. So I'll let you do that. I don't think you need any help with that. Again, you're just filling in the formulas. All right, let's jump down to 13. All right, on 13, I need to first determine if I'm working with a sum or difference of sine or cosine. All right, so let me jump back over to my formulas just a minute. I want you to notice that your sine formula starts with sine and your cosine formula starts with cosine. Okay, so as I look at these where I'm going backwards, that's what I'm going to kind of focus on, is am I working with sine or cosine first? Okay, so on this one, I'm starting with sine. Because I'm starting with sine, I know this is going to be a sine question. Okay, if you're starting with cosine, it will be a cosine question. Real quick, I'm going to change this from being all solutions to being between 0 pi and 2 pi. Okay, let me change that real quick. That's all they're ever going to ask you for on a test is solutions between 0 pi and 2 pi. Okay, all right, the next thing we're going to do is, wait for something.
The bottom half of the ID.
Oh, gracious.
Broke off.
Oh, no, I haven't seen it. Do y'all see Kaylee's bottom half of her ID? Oh, there it is. Yay, you found it. Good, good. All right. Next, I'm going to look for what are my alpha and my beta. Notice that they repeat as you go across. Okay, so alpha and beta repeat as you go across. So alpha is going to be 3x and beta is going to be 6x. The last thing I need to know is if I'm adding or subtracting. In a sine formula, I'm going to use the same sign that I have right there. In a cosine formula, they're going to be opposites. So watch out for that. Okay, so sine is the same, cosine is opposite. All right, I'm going to go ahead and do my 3x minus my 6x, which gives me negative 3x. And now I need to go and do something kind of crazy. Okay, what I'm going to do here is look at my even and odd identities. Okay, so we wrote these down yesterday. You don't have to go find them, just watch mine for a minute. But on Exploration 4.5.1 yesterday on number 3, we wrote down that for sine, if I have a negative on the inside, I can pull that out to the front. For cosine, if I have a negative on the inside, it just disappears. Okay, but for right now I'm working with sine with negative 3x, so I'm going to pull my negative sign out to the front. So that's going to give me negative sine of 3x. Okay, and again, I can do that because sine is an odd function. Okay, we talked about those formulas yesterday. So sine and tangent, if you have a negative with your angle, you can pull it out to the front. Cosine, if you have a negative with your angle, it just disappears. Okay, all right, I'm going to move that negative over to the other side. It's like I'm dividing by a negative 1. So that's going to give me negative square root of 2 over 2. Okay, again, it's been a little while since we solved equations, so let me remind your brain about a couple of things with solving equations. The first thing I want to do is find my reference angle in the first quadrant. I'm going to find that by asking myself, where is sine just the square root of 2 over 2? So I'm going to ignore my negative for just a minute, and I'm going to ask myself, where is sine the square root of 2 over 2? All right, that's going to be at pi over 4. All right, then I'm going to look at my all students take calculus, and I'm going to ask myself, where is sine negative? So sine is negative in the third and the fourth quadrants. Okay, so I'm going to keep my 3x, and I'm going to say that in the third quadrant, my over 4 angle is 5 pi over 4. I'm going to leave a little bit of space. You'll see why in just a minute. And in the fourth quadrant, I'm at 7 pi over 4. Okay, now if that had just been x, those would be my answers. If that had just been x, those would be my answers. But right now I need to get x by itself. We're multiplying by 3, so to get x by itself I would divide by 3. But because I'm working with fractions, I'm going to multiply by 1/3 instead. So that's going to give me 5 pi over 12. And this one's going to give me 7 pi over 12. Okay, so again, it's been a minute since we solved equations, so go back and kind of look over some solving equations. Okay, questions on that one? Okay, flip over on the back side, and I'd like for you to work together to try number 15. Try number 15, see if you can come up with what you have for that. So again, start with, are you working with sine or cosine? Find your alpha and your beta, and then determine if you're working sum or difference. I've had a lot of questions today about where does the 2x go. What I did here, first of all, I know I'm working with cosine because it starts with cosine. Then I'm working opposite sine. Cosine works opposite sine. This is my alpha, and this is my beta, and they repeat over here, alpha and beta. So what I did was 2x minus 1x, which gives me 1x. So the 2x doesn't disappear. It's just that when I subtracted, there was only 1x left. Does that make sense? Okay, so I've had a lot of questions about that today. Okay, the only place where cosine is equal to 1 is at 0 pi. Again, because we just had parentheses on 2 pi over there on the front side, I'm not going to include 2 pi. If that had been a bracket, I would include 2 pi as well. Okay, any questions on number 15? Okay, let's look down at the bottom because I assigned 6 questions down here at the bottom. But what I want you to see is that you've already worked all 6 of these. Okay, so please do not go and rework numbers 19 through 25. It's going to take you a lot of time. Okay, what they want you to do is look at your even and odd identities. Okay, that goes back to exploration 4.5.1 again, where on number 3, we said that if sine has a negative with its angle, I can pull the negative out front, and if cosine has a negative with the angle, it simply disappears. Okay, so let's work with number 19. So with number 19, I'm going to take that negative that's with my angle, and I'm going to pull it out front. Okay, now here's why you don't have to do a lot of work. Because we've already found the sine of 105 over here on number 1. Do you see how they go together? Okay, so 1 and 19 go together. So we already found the sine of 105 to be the square root of 6 plus the square root of 2 over 4 right here on number 1. So on number 19, my answer is just going to be negative square root of 6 plus the square root of 2 divided by 4. Okay, and every single one of them is that way. So number 20 goes with number 2, and number 21 goes with number 3, and then it skips down, and 23 goes with number 5, right? Yes. Okay, and 24 goes with number 6, and then 25 goes with number 7. So let's take a look at 25 because we already worked number 7. Okay, so again, Please do not rework them. Go to the front side and use the answers that you already have. Okay, 25, we're working with an even identity with cosine. With cosine, if the angle is negative inside here, then the negative just disappears. Your negative angle and your positive angle get the same value. Okay, so with cosine on number 25, I'm going to say that that's the same thing as 5 pi over 12. I can just let the negative disappear. And now I'm going to flip over to number 7. And on number 7, we found our answer for the cosine of 5 pi over 12 to be the square root of 6 minus the square root of 2, all divided by 4. So again, the point here is please do not go and rework them. They all go with something that's on the other side. Okay, okay, any questions on that one?
For 25, what did you change?
Nothing. I took out the negative because my even identity for cosine says that if I have a negative angle, it's going to have the same value as the positive angle. So I just let the negative disappear. Yeah, good question. Okay. Okay, all right, we need to do 7 and 8 on your exploration from yesterday, and that's going to lead me into double angles for today. So flip over to yesterday's exploration where we had exploration 4.5.2. We did the proof on numbers 4, 5, and 6, and now I need to talk about numbers 7 and 8 just a bit. All right, so on exploration 4.5.2, I'm going to flip over on the back side, and I'm going to take a look at numbers 7 and 8. Okay, number 7 asks you to take the cosine difference formula and change it to a sum, and that's what you get right there. So the point being that with cosine, your sine here is opposite from your sine here. Okay, so if this is a positive, then this is a negative, or vice versa. Okay, again, that's one of those formulas that I'm going to give you on the test. Okay, but I need it to work number 8. Oh, lovely. Oh, and I've been meaning to charge my computer all day. Okay, on number 8, what they want us to talk about is what if beta and alpha are the same thing? Okay, what if you have 2 of the same angle? And we're going to call that a double angle. That's what we're going to refer to them as. Okay, instead of using phi, I'm going to use alpha on all of these just because it's a little bit easier to use. Okay, so I'm going to start by thinking about the fact that if I have 2 alpha, that's the same thing as the cosine of alpha plus alpha. Okay, so just like x plus x gives me 2x, alpha plus alpha gives me 2 alpha. Okay, I'm going to go plug into my sum of cosine formula, except that I'm going to use the same variable for both. Okay, if you prefer to use theta or something like that, that's fine as well. But I'm going to use the same variable for both of these things. So over here, I'm going to have cosine alpha minus sine alpha. Okay, so basically I use the same variable for everything over here. So every angle gets the same variable. If you wanted to use theta, because that's a little bit different, that would be okay as well. So that'd give me cosine theta minus sine theta. Okay? All right. Times x gives me x squared. So what's cosine times cosine going to give me? That's right, cosine squared. Good. Okay, so my formula for the double angle of cosine is going to be cosine squared minus sine squared. And that's where it comes from. We could do the same thing for sine. We could do the same thing for tangent. Okay, so the sine double angle formula comes from having 2 of the same angle in the sum formula for sine. Okay. I'm not going to take the time to do those proofs with you. I will tell you that, again, all of these formulas are right here on Schoology, so if you didn't grab those in your first picture, make sure you have those as well, and those formulas will be given to you on the test tomorrow and on the UT test in a couple of weeks, okay? So you do not need to memorize the double angle formulas. Okay, let me show you how we use them. So jump over to your double angle homework. It says 4.5.2 double angles on it, right there. Oop, you can't see. Right there. Okay. So let me show you how we use our double angle formulas. Okay, the nice part about double angle formulas is that we're going to use triangles to work with them a lot. And so we're going to go back and use SOHCAHTOA. So a lot of people like these a lot better. Oops. Like that. Okay. So the first thing they're going to do is they're going to tell us how to draw the triangle. All right, so number 1 tells me that I'm going to draw a triangle where sine is 1/4, and I'm going to draw my triangle in the first quadrant. So in the first quadrant, x is on x, y is not on y, theta is at the origin, my hypotenuse is always positive. So just like all of the triangles we've been drawing, same thing. Okay. They've told me sine, so that's going to be my opposite over my hypotenuse. Okay, to find my missing side, I'm going to use Pythagorean theorem. So I'm going to do legs squared plus legs squared equals my hypotenuse squared. So 4 squared gives me 16, and 1 squared gives me 1. So I'm going to say that my missing side is the square root of 15. There's the square root of 15 now right there. Okay, so here's my adjacent, here's my opposite, and here's my hypotenuse. Okay, so now I'm going to jump in and start filling into formulas. The first one they've asked me to do is my double angle for sine. My double angle for sine formula looks like that. And again, they're over here on Schoology. You can go and use them right there. They use thetas. I'm going to use x. It doesn't matter. Either way is fine. Okay. All right, I'm going to start with my 2 from right here, and I'm going to put that 2 over 1, and you'll see why in just a minute. And then I need to fill in something for sine, and I need to fill in something for cosine. And I'm going to get those values from my triangle. All right, so let's start with sine. Sine was given to me, or if it isn't, I would do my opposite over my hypotenuse. And cosine is going to be my adjacent over my hypotenuse. Okay, and then all we need to do is multiply. So I'm going to multiply top times top times top. That's going to give me 2 square roots of 15. And this is why I put the 1 on the bottom, so I can do bottom times bottom times bottom, which gives me 16. And I'm going to reduce that to the square root of 15 over 8. Okay, any questions on sine? Okay, cosine has 3 different formulas. You can choose which one you want to use. It does not matter. You'll come out with the same answer either way. I like the first one just because then I don't have to worry about the -1 having a common denominator. So I'm going to use that cosine squared minus sine squared. But if you'd like to use one of the other 2, feel free. It's completely up to you. So this is going to be cosine squared minus sine squared. I keep jumping back between theta and x. I'm sorry. Either one works. You can use x for your angle, or you can use theta for your angle. It's up to you. Okay, let's fill in what we have. So again, over there on my triangle, I'm going to use my adjacent over my hypotenuse. And I'm going to use my opposite over my hypotenuse. So cosine is adjacent over hypotenuse, sine is opposite over hypotenuse. And when I square a fraction, I'm going to square the top and square the bottom separately. So what's going to happen when I square my square root of 15? 15, yeah, good. Over 16. And 1 squared gives me 1. Over 4 squared gives me 16. And again, I like this formula because it gives you a common denominator already. So that's going to give me 14 over 16. Or 7/8. Let's gets kind of more numbery. I think that's one reason why I like it again. Okay, the last one. Tangent has a double angle formula. Okay, but I'm going to tell you that there's an easier way. Okay, so there's my double angle formula for tangent. But there's an easier way if you've already found sine and cosine doubled angles. Okay, remember when we worked with identities that tangent is equal to sine over cosine. So because I know tangent is equal to sine over cosine, if you've already found the double angle for sine, we did. And if you've already found the double angle for cosine, we did. You can simply plug them into this formula. And that's going to be the square root of 15 over 8 divided by 7 over 8. It's a lot easier than using the tangent formula. I promise it is. I used it second period. This way is a lot easier. Okay, I've got fractions being divided. I'm going to keep it, change it, and flip it, and let my 8's cancel out, and that will leave me with the square root of 15 over 7. Okay. Again, it's a lot easier than using the formula. We came out with the same answer either way. Okay. Yeah.
What is
The formula, right here. Whoop. Oop, you can't see. There we go. Looks like that. 2 tangent theta over 1 minus tangent squared. Then we had to rationalize the denominator and find the common denominator and all kinds of things. And then second period, I remembered you could do second sine over cosine, and my life got a lot easier. May as well make your life a lot easier, too. Tell me.
Or if we had the sine 2x and the cosine 2x?
Yeah. So tangent is equal to sine divided by cosine. Yeah, good. Okay, I'm going to assign number 2 on here. So I'd like for you to try number 2 in just a little while. I'm also going to assign 3, 5, 7, and 9. And I'm going to show you how to work number 3. Okay, so you can omit all the evens at 4, 6, 8, and 10. I'm going to assign number 2, but then you can omit 4, 6, 8, and 10. Okay, on one like number 3, this is the reason why we have double angle formulas. I don't know the exact value of the cosine of 22.5. What I'm going to do is I'm going to go backwards. So I'm going to start by looking at this formula and seeing what it matches up with over here on my formula list. So my question asked me about cosine squared minus sine squared. So here's cosine squared minus sine squared right here. Okay, so I know that I'm working a double angle for cosine formula. Okay, so back over here, I'm going to work a double angle for cosine. Okay, what I'm going to plug in for my angle is whatever angle they've given me right here. Notice that they're the same thing. I'm going to plug it in once, like that. Okay, I know that 2 times 22.5 is 45 degrees. And I know what the cosine of 45 degrees is, and that's the square root of 2 over 2. Okay, so on 3, 5, 7, and 9, that's what they're asking you to do, is figure out if you're working sine, cosine, or tangent, figure out what your double angle is, and then find that value on the unit circle. Okay, so on 3, 5, 7, and 9, that's all they're asking you to do. Okay? All right, flip over on the back side. All right? Because it's a double angle. So double your angle. Yes. Yeah. Good. Okay. On the back side, I'm going to assign 11, 12, 13, and 15. And we're going to work 11 and 15 together before you leave. Okay. So 11, 12, 13, and 15. There are no proofs on the test, so I think we can just omit that 19 through 24 down there at the bottom. I think just the solving equations is all we need. Bless you. Okay. When we're solving equations on these, what we want to look for first is which double angle are we working with. On number 11, I've got my double angle working with sine. Okay, as opposed to on number 13, I have my double angle working with cosine. Do you see the difference? Okay, so look for where literally your double angle is. Which angle are they doubling? Okay, I'm going to take that sine of 2t and I'm going to replace it with my double angle of sine formula, which again is on your formula sheet, and you do not need to memorize that. But there's my formula right there. Okay, so I'm going to keep my 6 out front, and I'm going to replace the sine of 2t with 2 sine cosine. And then I still have plus 6 sine t. Okay, so I took sine of 2t out. I replaced it with its formula, which is 2 times sine times cosine. Okay. All right. Next, I'm going to look for some kind of factoring because I'm solving an equation. I'm going to try to see if there's something I can factor out. Okay, so there's 2 things. What are the 2 things that both of these have in common? That's right, a 6 and sine t. That's right, good. Okay, if I take 6 sine t out of the first piece, I'm left with 2 cosine t. Got ahead of myself. And if I take 6 sine t out of the second piece, it all disappears, but I need to use 1 as a placeholder. And I use 1 as a placeholder so that if I were to redistribute this into here, I would get that 6 sine t back. So if I use 0 right there, everything goes away. Okay, so be sure and use 1 as your placeholder. Okay, all right, I have factored. I can now take my factors and set them equal to 0. And I'm going to move this one up here so that I have a little bit more space. Okay, on this piece, when I divide by 6, the 6 goes away because 0 divided by 6 is still 0. All right, and I'm looking for where I have values of sine that are 0, so that will be at 0 pi and 1 pi. And again, I don't want to use 2 pi because 2 pi is not included right here. Okay, if I had a bracket right there, I would include 2 pi. Okay, over here, I'm going to subtract over my 1 and divide by my 2. All right, so my reference angle where cosine is 1/2 is pi over 3. I know that cosine is negative in the second and third quadrants. So in the second quadrant, my over 3 angle is 2 pi over 3. And in the third quadrant, it is 4 pi over 3. So that one had 4 answers. Questions on that one? Okay, last one for today. Let's take a look at 15. I'm going to help you get started on 15, and then I'm going to let you work together and see if you can solve. The first thing I'm going to do with one like number 15 is I'm going to move my cosine over to the other side using subtraction. Okay, so see if you can go from there. Replace your double angle with the double angle formula, take out your common factor, and solve. What is it? Oh, yeah. no hurry, but if you're ready, you can check your answer. So again, I was replacing my sine 2t with my double angle for sine formula. So 2 sine cosine. This time I took out cosine like a common factor because they had cosine in common. So that left me with 2 sine t minus 1. Use 1 as a placeholder. And then set both of those pieces equal to 0. In this case, cosine is equal to 0 at the top and bottom. So pi over 2 and 3 pi over 2. And then sine is positive in the first and second quadrants, and 1/2 at pi over 6 and 5 pi over 6. Any questions on that? Okay, so again, test on Thursday. You can work together and use your notes. I will take up all of the homework. All of the homework is over there on the sideboard. If you would like to take a picture of that before you leave, help yourself. Very good.